Hello everyone, welcome to Applied Internet of Things or Applied IoT Lecture number 5. I hope everyone is doing well. Before going into the content that we have to do, let's first look at a summary of what we have discussed in the last few lectures, right? So the table of content, right, we have taken an introduction to most of the things that we are going to talk in applied IoT. So we first started with the introduction to IoT. Internet of Things or IoT describes the network of physical objects or things that are embedded sensors, actuators, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet, right? So we got an introduction to IoT. What is IoT? What are IoT devices? We went through examples of IoT devices. As you can see, we looked at cameras, temperature monitoring control systems, smart lights, motion sensors, contact sensors, smart plugs, smoke detectors, air purifiers, control centers, and we went to robot arms that are used in manufacturing, and smart fridges, Roomba vacuums, smart locks, smart hospital beds, virtual reality gaming, so on and so forth, autonomous driving, health monitoring, and weather monitoring. Then we looked into applications of IoT devices in the real world. We talked about how weather monitoring IoT devices can share real-time data through the internet to temperature control units inside smart homes or thermostats, where these thermostats can get real-time data of the environment and do necessary adjustments either to the AC or the heating system of the house or the building to maintain a comfortable temperature for human beings. Then we talked about how a certain scenario, when there's a fire, how a IoT system could handle it by itself, the automated part of handling the fires from the sprinkler system, and as well as the notification about the fire to the relevant people, maybe the people inside the building, owners of the building, the fire department, and other officials. And we talked about how that can be carried out as well. Then in another example, we talked about how a set of or a specific IoT which delivers a specific purpose or monitors the weather can that particular set of data can be used in different scenarios or different domains. Now we first talked about how smart lights in a home, a city, and in buildings can be used from that real-time data which is shared from the weather center, from IoT devices in the weather center. Then we talked about how these real-time weather information can be shared with other domains, maybe people who are going on remote traveling, hiking, things like that, airports, people who are going on fishing, and so on and so forth. So different domains can use the same data. We talked about how different domains can use the same data which is obtained from IoT devices. So we looked at how one IoT device or one IoT system that tracks real-time weather properties can affect or can be applied, those data can be applied to different sets of domains. So we looked at those, and then we looked at how IoT devices can be used in different industries and domains. We mixed and matched them, how each domain can use each IoT device for different purposes with different importance or intensities. For example, if you have a health monitoring IoT devices, it is more relevant to healthcare sector, but those monitoring devices can also be used in highly industrial locations, or manufacturing plants or heavy duty manufacturing plants, to check the safety of the human beings as well. So like that, we went on to understanding how IoT devices can be applied. Then we took an introduction to applied IoT. Applied IoT refers to the practical application of Internet of Things, IoT technologies and solutions in real world scenarios across various industries and domains. It involves using IoT devices, connectivity, data analytics and cloud platforms to solve specific challenges, improve processes, enhance decision making and create value. So this was the definition. In that definition, we mainly concentrated on when applying IoT solution, why we apply IoT solution is to solve specific challenges, improve process, enhance decision making and create value. Then we talked about different with industries and domains. Right, we briefly touched upon consumer products, smart infrastructure, security surveillance, healthcare, retail industries. Others would include logistics, transportation, warehouses, agriculture, power grids, so on and so forth. We talked about how IoT can be applied in each and every domain. Right, even if you talk about each and every domain, we looked at examples how a specific set of IoT devices, which the information that has been created by those IoT devices can be used in different domains and activities. Here also, if you take agriculture, that would be this set of data can be used in agriculture, even in power grids to depending on the weather, the safety features can be enhanced, right, things like that. Even we could see that different domains and industries can use the same data set in different forms. So that means there is a potential of if you take the financial side of it, if you have IoT devices and if you have devices that monitor the weather itself, that data can be shared or that data can be sold in the market for any industry or anybody who is looking for that data to have financial gains, right? So slowly by slowly, then we can understand how IoT is applied. Before going into IoT applications of IoT further, right, we should understand what are the characteristics that we will see in IoT, or if you have a IoT application or IoT system, what are the characteristics or what are the properties that you will see. In this, we talked about connectivity, sensing and perception, right? So basically connectivity is the networking part of it, sensing and perception is the hardware part of it, data analytics would be the cloud part of it, right? We talked about automation and control, that is automation and control would mainly come for industrial section, but in smart homes also we can find automation. The scalability, the ability to scale the application that we have done, right? We talked about how IoT has that property. Security and privacy, of course, when you have networking and sharing of data, security and privacy comes into play. Real-time communication, we talked about it, real-time weather data sharing. Heterogeneity and edge computing. So edge computing is a part of the devices having the ability to process the data that it obtained, and heterogeneity is the part where the adaptability of the particular IoT device to different technologies and protocols. These when you learn learn the engineering part of or the architectural part or the engineering part of IoT, you will understand that there are separate protocols that are there for IoT devices which consumes less energy because the amount of IoT devices which are being used, and to make them efficient and to share only the data which is relevant, not all the data but the data which is relevant, heterogeneity and edge computing techniques are being used. Then we talked about machine to machine. Before going into machine to machine, I want to take your attention to a particular set of diagrams. This part is from IoT course, right, where the goal is to build an embedded IoT device. But I wanted to give your attention to this because mainly this would give a brief understanding of what is a IoT device and how the IoT device a set of IoT devices creates IoT system, and how these systems talk to each other, and how the automation takes place, and what are the parts or what are the we can see the characteristics in this diagram itself. So let's start from one corner of this diagram, which would be the IoT device. These IoT devices would be the devices that we talked about as examples, right? It's not only that, right? These devices that have the ability, right, the ability to so these when we talk about these IoT devices, one of the main points that we have to talk about is that there is a connectivity. The one of the characteristics is connectivity and sensing and perception, right? When we talk about the introduction, sensors and actuators and the processing ability, right? In an IoT device, the main hardware characteristics would be sensors and actuators, right? To determine in the distance between two things, or to understand whether there is contact taking place or not, or to understand where there is heat or not, or if there's motion, to control electricity, things like that, right? So in that perspective, right, in that case, so sensing and perception, so this is it has the ability to detect temperature, humidity, motion, light, pressure, and various other types of so these sensors have the ability to detect these things. That is the main hardware component of it. So a IoT device would contain sensors, right, would contain sensors. Now if you go up here, right, if you, this is the other lesson, I'm just going a little bit away from that lesson to remind you what is a IoT device and what's inside a IoT device. Now if you see this see this example inside these IoT devices, if you take the robotic arm, you will see there are motion sensors, there are proximity sensors, there are gyroscopes, there are imaging sensors, magnetometers, relays, servo motor, in the perception layer, these are all inside, these sensors are all inside this robotic arm. Why these are inside this? It is there so that it can get data to carry out its actions, right? Let's take the proximity sensor for example. So we have seen dozens of videos where these arms move around, go near an object and try to work on the product, but we haven't seen it going and crashing into that particular build. If you see a manufacturing line in a let's say a manufacturing of vehicles, BMW, Benz or Toyota, Nissan, anything, we would see these robotic arms working on vehicles, but we don't see them going and crashing into each vehicle body. Why? If you see why is that, there would be proximity sensors with the arm itself. If there are no proximity sensors, there will be magnetometers to either detect, or there will be motion sensors, or there will be image sensors which use image processing software to understand how close the object is to the robotic arm itself. Some kind of solution is derived through these sensors. Therefore, the arm will not go and crash into the body of the car and damage the product. So this is very important. We will see gyroscopes will be certainly there to understand whether the product is on the right side up or in the right orientation, and to understand the surroundings. So things like that. So here we can see, if you have the smart fridge, you will have pressure sensors, humidity and temperature sensors, gas sensors, sound, image sensors, right? If you go to smart smoke detectors, you will see humidity and temperature sensors, gas sensors, and so on and so forth. You will be able now that you can see that each IoT device is made out of one or more sensors, right? Those sensors will be giving out or producing raw data all the time. Not only that, IoT devices then again is made out of actuators, right? Actuators, so these are the physical components of it. So in actuators are servo motors, relays, we have normal motors, geared motors, valves, pumps, speakers, screens, so on and so forth, right? So this arm to move in a certain pattern, this arm to carry out its function, there will be servo motors and motors, definitely. And if there are motors, and if this is heavy machinery, right, if the robotic arm is a heavy one, larger in size to handle heavy products or things like that, then it would be basically there will be relays to handle the electricity consumption in the system itself, right? So if you take a Roomba, of course you will, there is a vacuum inside it, there is motors moving the this Roomba vacuum up and down in a path. There will be servo motors, so there will be other motors to change the orientation or change the position, the traveling position of it, turn left or right or 360 degrees. It has the ability to do that. There will be small sweeping fans under it, that would be also working with motors. So that means there are a lot of actuators inside these things. If you have AC, then you will definitely have a pump. If you have a fridge, there would be cooling taking place, and for that cooling to take place, you will need pumps in action. You have to have pumps working so that the cool air is circulated properly, right? For these things, actuators are needed, right? If you have smart smoke detectors, the first thing, the primary thing the smoke detectors would do would either give a sound, alarm, and that alarm would need speakers. So that means there's an actuator again working, right? So in that case, we know that sensors and actuators, either one or a combination of these actuators and sensors, or one sensor or one actuator would be there on an IoT device, right? Normally actuators would take in commands and sensors would produce raw data. So when raw data is produced, that sensor should be connected with a processor or a processing unit, or we can say embedded system, right? When we are developing a IoT, normally we will use Arduino or Raspberry Pi, so that to carry out the necessary processing. So that means that raw data which is being produced in the sensor will be communicated to the processing unit, and that processing unit would keep on processing data till some parameters are met. When those parameters are met according to the code, right, commands will be given out. When commands are given out, the commands will go to the actuators to carry out the function, right? If you take this robotic arm, right, because this is a industrial scale example, I will take this, right? If it wants to move forward, the motors will start working, it will move forward, and when it comes near an object, the proximity sensors will trigger and inform according to the code, or you are going near an object, do not crash into it. So the processors will process that data and run a command to the actuator, which is the motor in this case, to stop moving, right? So these things are done inside the IoT device itself, right? But another example we talked about is the IoT sensors that are being used for weather monitoring systems. So in this case, right, the sensors are in one device, the actuators are somewhere else. You can see that the actuators are somewhere else or in another system, right? So in that case, if there are only sensors, and those sensors will detect the information and process the raw data, and that raw data can be communicated to other IoT devices inside the same system. If you think about it, if you have one or two devices which monitor the sunlight intensity along the road, maybe 200-300 kilometers road, there will be couple of sensors to detect the information and relay it to other IoT devices, means by the network, right? That sensor will detect that the either the intensity of the intensity of sunlight is low, and that data will be processed and a command will be sent through will be created in the processing unit, sent through the networking system into the IoT or the lights on the road, where they will switch on. So that itself would be a IoT system. But if the data is coming from outside, that means each IoT device which is connected to each other, like here you can see couple of devices connected to each other. Those devices will be, that would be a whole system, and that system would be connected to the internet itself, to the cloud, right? Where the information or the data which is being created from these devices will be stored, analyzed, processed in a manner. So basically, using cloud resources, we can run our algorithms, right? If you take weather information, right, there are specific algorithms that they can run and predict the future of the weather. If that is the case, we can use cloud resources to do that heavy lifting, right? Now, before going into other places, so we talked about connectivity. We can see that their sensors are connected to processors, and normally a IoT device is connected to other IoT devices, creating a network of its own. So sometimes when these devices are connected to each other, let's say if you have a 50-story building and you have a set of smart smoke detectors, that you will have hundreds and thousands of smart smoke detectors. So we cannot have our Wi-Fi system, or we cannot have our general networks being flooded with the data that is being produced by these IoT devices. So there are protocols and networking systems. By now you know Zigbee or Z-Wave, things like that, right? Protocols which networking protocols which are dedicated to IoT devices and IoT networking. What it does is that it will free up local Wi-Fi or local networking systems, and these dedicated IoT networking protocols consume only a small amount of electricity as well, so it is efficient. So some devices, some IoT devices would run on battery power as a power source. In that particular scenario, it is better to have the lowest consumption of electricity to have the IoT device work for a long time efficiently, right? So in that scenario, so the internal networking of IoT system could be either internet protocols itself, it could be Wi-Fi, Bluetooth, cellular, things like that as well, or inside IoT devices, depending on the architecture, it would be IoT dedicated networking, right? The connectivity would be IoT dedicated networking, which would be Sigfox, Z-Wave, things like or Zigbee, things like that, right? But when it is steps out from the system to the internet itself, then normal internet protocols, right, the 7 layers of networking comes into play, and it system, so IoT system to system will be communicated likewise, the normal method of data sharing, right? Then after that, we talked about sensing and perception layer. Now we looked at actuators and sensors, right? We looked at the hardware layer of it, right? We now know we looked at what is inside a IoT device, what are the things inside, what it can do, right? We looked at it as well, right? So we know what's the hardware layer of it, would be data analytics, right? Data analytics, automation controls, scalability, right? We will talk about data analytics first. Data analytics, and we will talk about edge computing, right? Data analytics and edge computing happens in this stage over here in the processing unit, right? Edge computing is that we compute it inside the device and we carry out some protocol, right? We don't need to send every single bit of data to the cloud itself, process it and take it back in. We can do the necessary processes inside the device itself. For example, if you take the Roomba machine or if you take the robotic arm, right, the proximity sensors can detect and stop the machine from crashing into something, some object in front of it, without needing to communicate that information to a central processing place or a cloud or something like that, right? So it is efficient. It will reduce the stress on the networking itself, right? And it would be efficient and quicker. Decisions can be made through that. That is the edge computing part of it. Data analytics, if you take the data analytics part of it, right, the data would be analyzed here. The raw data which is being produced by sensors would be analyzed here. All the data which is being produced by all IoT devices would be sent into cloud processing, where you can find big data processing methods to do such things. So all IoT systems can use the cloud, right? That data which is being produced by different IoT devices can be taken into the cloud, right? And that big data can be processed accordingly. So that part of it, process of big data, how the cloud functions and things like that is, if we start talking about those topics, we will be going out of IoT. But as you can see, because in the world of IT, everything is normally combined, right? If you are saying we are going to produce a large scale amount of data, it would be from IoT devices. That would be big data, and then there will be that data would be, if that data is processed and fed into a AI model, then the AI would come into play, right? So things like that. So if we are going to go towards that, we have to talk about artificial intelligence, cloud computing, big data, so on and so forth. So yes, of course, everything is connected together for now, right? We can use a general term as cloud processing for that, right? Automation and control. Automation and control is basically, right, we can automate. If we can write a code when the intensity of the light becomes this much low, the value becomes this much, switch on the lights. So that is basically automation. So the automation part, right, it makes the process more easier in that sense. So the scalability of it is, as I told you, in IoT system, the scalability part of it is because there are protocols dedicated to IoT devices. In an IoT network, we can keep adding IoT devices to that network, right? So in this IoT system, we cannot say, oh, there will be 40 devices or 30 devices. It is an n number of devices. Depending on the criteria, depending on the need, there will be a lot of devices added into each system, right? Each IoT system, right? Depending on the need of it, or depending on the different requirements of it, we have to do so. For example, if you have a high-rise building, right, and you have a floor entire floor and there's one entrance. That entrance would have a smart lock, right, which is an IoT device. But if they decide to divide the office into two and have two doors to enter separate two units in that office building, there will be now two smart locks connected to the same network, same IoT network. So then the IoT network should have the ability, the capacity to take the new IoT device into its network, right? So that is the scalability aspect of it, right? Then we talked about security and privacy, of course, encryption, access control, and so on and so forth. When we talk about any technology, security and privacy is a common scenario, right? So the protocols, from protocols to firewalls to so on and so forth, right? If you are familiar with networking and everything, you will say, okay, there should be a firewall here or firewall here, right? Things like that. Of course, there should be, there is, right? This is a general aspect of IoT systems, talking to IoT systems. Generally, yes. And if you if you are building your network inside like networking your own IoT devices together, depending on the data that is being shared, how sensitive the data which is being shared, right? Encryption protocols and other protocols can be used for security, because you can say, okay, we are going to use a IoT system in a military base. It would be completely different from using IoT system in a smart home. So things like that. Heterogeneity, real-time communication, we talked about it. So part of the edge computing, so part of the processing happens here, and when the data is needed to be communicated in real time, we can do it through the networks itself. Only the needed data will be passed on, right? Not all the raw data. So decreasing that will decrease the stress in the system itself, right? And although the needed data will be passed in real time for all devices, so through the internet to other IoT systems to function the way they want. Then heterogeneity, right? So encompasses wide range of devices, technologies, and protocols. So if you take this IoT system, we can take different examples. So if you take a single scenario, IoT system would be weather related IoT system. In that IoT systems, there will be different kinds of devices. One to detect the sunlight, one to detect humidity, one to detect the wind speed, one to detect the moisture, one to detect the temperature, so on and so forth. There will be different sensors and different devices. All these devices would be producing data. That data needs to be read by a collective place, right? If we are sending it to a cloud-based unit or a single application, if we are going to show that information in a single application, we have to make that data into a format where acceptable for everybody. So that is the main part of it. When you design a IoT device, it is necessary to have those protocols built in so it can be adapted to different IoT systems, because this device would be created by one manufacturer. This would be created by another manufacturer. This would be created by another manufacturer in another country or another place. So in that particular way, if we are to build a IoT system, these devices should be able to talk to each other. The one of the best and common examples would be the control center. We talked about Alexa, right? There are devices created by third-party manufacturers which has the ability to integrate with Alexa, and that would make it easy to be set up in a smart home. That is the point when we talk about heterogeneity. Then edge computing. Yes, we talked about edge computing when we were talking about data analytics in the cloud, right? Data analytics happens in the cloud itself, but there's a part of the sensor data and commands for the actuators will be processed in the device itself. That is edge computing. So this is how IoT works, right? Internet of Things. The data which is being produced by some IoT devices are used internally, right? If you have a large manufacturing plant, right? If you have robotic arms working on that manufacturing plant, the data which is being produced by that device will not help other IoT systems. It would only help that manufacturing plant, most probably, and that would be kept inside. So that would, the data which is being produced by that or any data about the errors or any tweaks that is needed to be done, any calibration data and things like that, would be kept inside a private cloud rather than the cloud itself. But if you take weather data, right, that is something that is being freely available in the cloud itself, or we can pay to get that service as well. That means that there is a financial aspect to it, which so that means there are value chains created. So we are talking about devices, right? We are talking about IoT devices being manufactured. We are talking, so in this case we are slowly moving into our applied IoT topics. In the applied IoT topics itself, right, you will see that there are IoT devices to be manufactured. There are internal components of IoT devices such as sensors, processing power, networking devices and actuators to be manufactured. There is a vast network that is needed to be taken care of as service providing. The IoT system, taking care of the IoT system is one part of it. There is cloud computing, right? So that part would come. That means there would be applications for humans to interact. There is the aspect of that, and one of the main aspects of it in the industry of IT, right? If you take Facebook, if you take Instagram, if you take TikTok or whatever, what is the basic concept of them? How they run large scale clouds, they run large scale servers. They have thousands of employees. They need to pay their salaries. They need to pay the electricity bills. They need to buy the hardware equipment. They need to carry out all those things. But how do they provide the service to the individual? So normally the saying goes is that the individual is the product. It's not the service. So that means the data which is being collected from us is given to ad companies, right, to modify and to target each individual with ads to get the maximum outcome of it, right? So ad revenue is the way. in this, right, before going into applied IoT deeper, right, so one of the points that we can talk about is that we can see IoT devices, because they generate data, the sensors, especially the sensors generate data, and that data has value as well. So you can see that there are building the hardware devices, right, IoT devices, maintaining the networks, maintaining, collecting the data, and getting financial benefits from that data which is being created from IoT devices. Running IoT systems and networks creates value, right? It requires a value chain. So slowly by slowly we are understanding IoT, applied IoT. We see that we need a value chain. Before going into that, right, we have to review a little bit more. So we talked about introduction to machine to machine. Machine to machine refers to the direct communication between two or more devices, typically without human intervention. It involves the exchange of data, commands, or information between machines, enabling them to collaborate, interact, and perform tasks automatically. So part of it is automation, right? We talked about machines talking to machines. If you go back to our IoT lecture examples here, right, you can see that this machine or this device has a set of sensors for it to work, and the data which is being produced by these sensors can be exchanged with the machine next to it, so that when one right, so when this arm moves and position itself in one location, which can be determined from either image processing, proximity sensors, or gyroscopes, that information can be given to the other arm, so that that arm would not clash with the arm next to it. So that means those two devices, the algorithms can be written in a way that those two can work together. You can see here in this picture that these arms are working together without crashing into each other. So that means these arms should be talking to each other, exchanging data about the positioning of each arm. Otherwise there will be clashes. We talked about pumping stations. Each motor will turn on depending on the pressure, right? So that means there will be sensors, right? So here this is not an industrial scale example. This is but this is a pressure sensor. So industrial scale sensors like this would be inside these pipes, determining which motor to be switched on or off. So those machines will be talking to each other. But here machine to machine is a little bit old concept. The concept was there before IoT came into existence, right? Because machines were talking to each other and automation was taking place before IoT came into play. After IoT also came into play, and with the integration of high-end processors, better sensors, better algorithms, and so on, right? Better chemistry, material science, building better chips, better sensors, and so on and so forth, gave the opportunity for M2M technology to behave in IoT, like IoT, right? So yes, we learn about IoT, and so the difference between IoT and machine to machine is a blur today, but there are differences, right? As the syllabus says, we can learn about them as well. So M2M is used in industrial automations, smart grids, transportation and fleet management, healthcare. So machines to machines talking. But if you take the examples as we talked about earlier, this means part of IoT, either IoT systems talking to IoT. So it today the difference between M2M and IoT is indistinguishable. It cannot be separated. So we have also smart cities, we talked about them as well. Then we talked about the difference between Internet of Things and machine to machine. There's a difference between the scope, the data sharing, the amount of data which is being shared, connectivity, scalability, right? Because these are legacy systems, right? Legacy systems, or these are heavy machinery which are being produced for unique purposes, the scalability would be low, right? The scalability of a IoT device such as a let's say cameras or temperature control systems, simple things like this, the scalability is really high. If you take a power plant or large scale turbines or things like that, the scalability is a little bit low because of the heavy machinery and so on and so forth. So we talked about the differences, data analytics and ecosystems, so on and so forth. But if we are to apply machine to machine systems today to increase the process or to build a new process, it would be like IoT. So there's another word like IT. There is operational technology, OT is there in also a terminology, also a term that is being used, right? So operational technology is the hardware and software that detects or causes a change, though the direct monitoring and or control of the industrial equipment as a process and events. So that means basically so operational technology is the hardware and software that detects or causes a change through the direct monitoring and or control of industrial equipment, assets, process and events. So basically again hardware devices being controlled. OT is a terminology that is being used in current status. M2M is a terminology that is being used before IoT. This is something which is being used today, right? So this is not on the syllabus, but I just added because this is something that is being would be spoken in some industries, right? So for example, in IT it's all about software, it's all about cloud computing, running data centers, networking, so on and so forth, running applications, databases, things like that. But in OT there will be a hardware component to it, and these hardware components will be generating data. Either it would be cameras, smart watches, monitoring systems, robotic arms, monitoring tools to monitor the consumption of electricity, the pressure inside valves, so on and so forth. That data will also need networking to be sent into control stations or control for human interaction and so on and so forth, and there will be a lot of data being produced. So there is so that is when a bit of IT where networking, database, cloud computing, database maintenance, building of databases, analytics comes into play. But the data itself is not produced like ERP systems or HR systems or things like it is not software as a service, right? It is hardware components producing the data. So that means there will be maintenance of the hardware itself, right? So you understand that as the IT industry, OT industry, IoT or M2M has its own uh, industrial power or financial power, so we need to have services as well as products. In IT sector, we would have IT software, custom made software, and then we would have systems, ERP systems, to manage logistics and so on and so forth. We have, if you take things like Dialog or Mobitel, you will see there are what do? They are a service provider, and that's their business model. They provide a network service to the country, and for maintaining and running that network service, they charge the individual who's using that services. So similarly, if you have hardware components which are running in a factory, or which are there in the monitoring the electricity grid and so on and so forth, those things have to be maintained, and software have to be built to monitor in real times, things like that. So there will be industries and value chains created around it, as Dialog or Mobitel, Hutch or anything would have value chains. OT side or IoT side or M2M side would also have value chains. So this is the point that we are in right now in our lecture. So we can start from the next bit of it. So now in the next part of our lecture for applied IoT, we will be now looking at the market perspective of IoT, right? Not only the market perspective of IoT, we are getting a small introduction to value chains, then M2M value chains and IoT value chains. We are not going to spend a lot of time in M2M value chains, because as we talked about before, M2M value chains are now becoming a part of IoT. So when we have an idea of what is a value chain and how it functions, then we will focus on mainly towards IoT value chains, and from that we could take an idea of M2M value chains and how these IoTs can work for M2M value chains. So the very first topic would be the market perspective. Talking about market perspective, we have to look it upon it in different angles. When what would actually affect IoT in the market space itself, right? So we are going to look at the market size and the growth of it, right? If somebody is going to start their first venture in IoT side or in IoT sector, of course it is important to understand the market itself, right? So first, the first thing that we are going to, so we are just going to look at what is the market, what is the growth of the market, what is future of the market. We talked about before when we talked about IoT and IoT devices, IoT systems, we talked about how markets can emerge from providing different services or providing different hardware equipment. So the IoT market has been experiencing rapid growth. Yes, we can say safely from around 2010 onwards, or even before that, a little bit before that, we are in the IoT sector. The market is having a quick, rapid, successive growth, a continuous growth in every domain and in every space. So the requirement of IoT and the development IoT is happening so fast, right? IoT has now become a product like AI, cloud computing, big data, virtual reality, uh, topics like that, which has defined the 21st century IT field, right? Information communication field. So we have rapid growth in this market, and going into the future, if you go through any article or if you go through any financial article and technological article, both of them, you will find out that IoT has, one way or another, has a space in the future, and its potential is vast. According to the market research report, the global IoT market size is projected to reach trillions of dollars in the coming years. When I read through some articles quite recently, right, it's still in the billions but close into trillions, and in the upcoming future years it will go for trillions and trillions, and we will talk about why it is so. The increase in adaptation of IoT across industries, coupled with advancements in connectivity, cloud computing and data analytics, are driving this growth. So we can see one of the main points here is that advanced connectivity is the word that we have to focus upon, because as I told you, if we are to use hundreds of IoT devices to monitor things, or if we are to use thousands of devices to monitor, the amount of load in the connectivity in the network will be greater. So to manage that, there should be proper protocols and the proper networking. So development in connectivity, right? Technologies like 5G, which gives more capacity, more bandwidth, more capabilities and fast communication, contributes to IoT, gives a new feature, gives the space to expand in the field of IoT. Cloud computing, we all know now, this has been widely used, and there are cloud-based service providers, mostly commercial, well-known, either Azure from Microsoft or Google Cloud or Amazon, AWS, they all provide tailor-made cloud solutions for IoT, right? So in the IoT itself, in the cloud computing itself, data analytics features can be given, right, for mass process of big data, right? Because as I told you before, IoT is a subject that creates a lot of data, right? Now the market size and the growth, right? We will a little bit talk about this and why we say that there is a big the market size of it is going towards trillions, and the growth is still going on. If you take countries like Sri Lanka, if you take countries like even India, right? India is a place where there are more than billion people, but are smart cities or solutions for smart cities fully implemented in that country? Or is any South Asian country has a smart city? No, it's not there, right? A fully functioning smart city is not there. If you take cities like even New York or London, cities which are old, and rather than building it from ground up, we have to tailor make IoT solutions for the existing legacy systems. Full adaptation, though we can categorize them as smart cities, the full adaptation of IoT we haven't seen. So that means that even though we have cities like Singapore, Dubai, which and newly proposed smart cities around the world, right? Even we can say our port city. So there are right. If port city is going to take place, we have the opportunity to make it a smart city. We have the opportunity to use IoT devices to make it a 21st century compatible city with IoTs working to make it a much more productive, efficient city. So there are two perspectives to it. That means we can see that in the domain of smart cities, which would need thousands and even hundreds of thousands of IoT devices working in tandem together, monitoring in sewer lines, water lines, gas lines, electricity lines, so on and so forth, right? Your Wi-Fi networks, cellular networks, inside smart cities, self-driving cars needed to communicate, security systems, your subway, your metro systems. So when we see that we can use IoT devices, traffic control, so on and so forth, the topics are endless. We talked about them. So when you see, there are two sides where we can see a positive growth. Number one is newly planned cities, right? In Saudi Arabia, there's a concept of the line. In Arab Emirates, still the cities are expanding. Cities like Singapore are moving towards have moved towards, and in the future whatever they do, it will be based on IoT, right? They will use IoT technology for monitoring purposes and conducting in their functions in the city, right? And if you take the vast quantities of cities around the world in the South Asia region, right, these huge cities, and if you take cities from Africa, right, which are cities that are coming up, Brazil, Mexico, these countries are coming up, like they are in a path of development, but they have legacy systems in their cities. So that means that the opportunity to introduce IoT for already built cities is still there. Tokyo or Shanghai or New York or Los Angeles, they might have integrated a lot of IoT devices to the existing smart city infrastructure, right? And they might be using it, but even London, like, and other European countries, but still there's a long list of highly dense, highly populated, large scale cities which still needs IoT solutions going into the future. So the marketplace is there. And on top of that, so we can see a market growth in that perspective. On top of that, if you take smart cities, the newly proposed smart cities from ground up is also increasing. There are proposals which are taking every year new smart cities, building from ground up, right? There is a a new city being built for administration in Egypt. There, Saudi Arabia is having its own projects going on, right? If we can get things moving in Sri Lanka, there's a port city as well. So that means altogether, if you take the domain of smart cities itself, which would need over millions of IoT products to monitor each and every situation of the smart city itself, we can see that still the market space is available, right? So growth would be there in that particular region as well, right? That is smart cities domain. If you go into smart grids, if you go into like mostly today multinational companies have turned their attention towards using digital solutions and automating things as much as possible, right? In that domain, IoT devices or implementing IoT solutions is less. If you take industries and so on and so forth, manufacturing industries and let's say steel manufacturing, cement manufacturing, these hardcore industries where it uses big amount of energy and big amount of machinery, heavy machinery to produce things. But then again, to maintain these IoT devices, if you have IoT system, right, in those industries, if the companies have already moved to IoT, that means the market space is there for either further development of good products or maintaining the IoT system itself. Then if you go to another domain like agriculture, the use of IoT is still at a minimum, right? And agriculture is something that if you take even the South Asian region, if you take South Asian region, the use of IoT is barely minimum. So one of the stories that if you go a little bit out of our topics, and one of the stories that is famous in Sri Lanka in scientific circles in Sri Lanka is that I forgot her name, but there was a scientist for nanotechnology, right? And she has created a sensor that that has the ability to detect the amount of fertilizer that is in the soil, right? So how can it help the economy, or how can that become a IoT, things like that? Right? If you look into it, right, when she developed that sensor, of course it was adopted by another country, right? It was not, she was not able to implement in Sri Lanka, so it was adopted by India. What India did was they used it around their entire country, or when they were testing. So what they found out was the amount of fertilizers that they use is more than, like, it is excessive. Around 40% it is excessive and it is not needed. Fertilizer, artificial fertilizer is a thing that is being imported to the country itself. So millions, even billions of dollars are saved for the Indian economy because now from that machine, that product, that sensor, which would be IoT, which would be a part of IoT domain, farmers can use it to check the amount of fertilizers in the soil and use the right amount, right? And they don't need to use excessive amounts because now they can have the ability to monitor the amount of fertilizers available in the soil itself. That goes to savings. If that when less fertilizer, artificial fertilizer is used, the price of the crop goes down. So the food in the market will be lower. Now you can see how the value chain works and how that simple product, that simple device, which we can categorize as IoT, it's a sensor, and that sensor, that mechanism has the ability to detect the amount of fertilizer in the soil in real time, and by taking that real time, farmers can adjust the amount of fertilizers they have to use to take the maximum product. So it is efficient and it helps the economy. It reduces the stress in the value chains. It gives the benefit of the reduction of value to the customer. So that is one implementation of IoT products, a hardware device that can monitor environmental changes in this case in the soil, right? Fertilizers in the soil or the nitrogen content on the soil, right? And that has a huge impact to the country itself, because it's not only one farmer. When you take hundreds of acres multiplied by millions, right? India is a huge country. The amount of resources needed to farm is 1,000 times more than Sri Lanka. If you see the map, you can see the difference. So that means the impact to the economy becomes huge. One farmer would be saving, let's say, $50-$60 or even $100, but if you have 100,000 farmers, right, $10 million are saved. So things like that. So but in the agriculture sector we were talking, so we will come back to our topic and we will talk about market size and growth, right? If you take the agriculture sector itself, in South Asian countries, we still need more automation in agriculture. We are working with very less automated devices which are inefficient under current standards. That means that in IoT has a market to grow in South Asia, in Africa, and even in developed economies where agriculture is taking place, right? So if you take from then that domain to, let's say, production of electricity, or let's talk about a domain which is specific to Sri Lanka, irrigation, the tanks we have, right? For example, Parakrama Samudra, to monitor the status of that tank itself, we would need at least hundreds of IoT devices around it if we want to monitor it real time, the water levels, to the structural integrity of the banks, because they are thousands of years old. So this is so if you take that marketplace, that is something unique to Sri Lanka itself. So that marketplace is, if that market to be built and to grow, that market will take place, that particular sector of the market in IoT will be taking place in Sri Lanka. And of course, those products which are produced to preserve the tanks in Sri Lanka can be then exported to other countries. So depending on different countries and their requirements, right? If you take countries like Singapore, Tokyo, Japan, small countries with large populations and large cities, commercial cities. If you take London, New York, then again, old cities, legacy systems, which but to bring them up to date, they have implemented IoT systems. And so whatever the situation it is, depending on which domain, which market, the growth is still out there. Especially in countries like, in regions like South Asia and Africa, right? The Middle East or the European regions, and even Latin America, we have Brazil, we have Mexico, which are rising countries, right? Their economy is also rising. So they would be also looking to develop their cities in up to standard, and will try to use IoT solutions to make their cities efficient. But that is only one domain, right? When growing economies takes place, there will be new companies coming into play. Each company, depending on their domain, would need IoT solutions. Either it could be logistics, right? If you take logistics of logistics taking place in African countries, Latin American countries, even in South Asian countries, there's still potential to build more road networks, train networks, flights, airports, ports, so on and so forth. Developed countries, if you take European countries, United States, Japan, Southeast Asian countries, Australia or China, still they are creating projects to build ports and logistical hubs. So that means, again, the market is becoming bigger and bigger and bigger for IoT, right? We haven't even touched defense industry, which in itself is a huge market for IoT. Security surveillance, that could be a part of defense. But again, if you take security surveillance for localized solutions for buildings, logistical hubs, houses, so on and so forth, that's another different market. So that means, if you are to build IoT devices, if you are to work on IoT devices, the future of the IoT sector as a market is very positive, and growth is there definitely, right? That is the main point from this. The market size is getting bigger and there is room to expand. So the market perspective for market size and growth is very, very positive for IoT. So the next market perspective would be industry adaptation. right? So how in that we can it is quite similar to the topics that we talked about, right? If you take what is being adapted, right, what is influencing the growth itself, we would see that industries or different domains adapting IoT and still yet to adapt IoT and get the benefits of usage of IoT is still there. So it is fueling the growth of IoT in market size. Right. IoT has found applications in a wide range of industries, including manufacturing, healthcare, transport, agriculture, energy, retail, smart cities, and more. In the above, before lectures, right, in lecture 1, 2, 3 and 4, we talked about IoT devices, and we talked about these industries and how these industries have moved to adopt IoT devices to make their industries more efficient, productive, and add value to their industries. So industries are leveraging IoT to optimize processing, improve efficiency, enhance customer experience, and create new business models. The adaptation of IoT solutions is expected to continue to expand as organizations recognize the value it brings. Yes. So in industrial adaptation, right, we talked about different industries. We talked in length about different industries and how those industries use IoT, right? And as different types of sensors are built, different types of new hardware technologies come into play. The solutions that can be derived from IoT, right, the hardware solution that is can be derived from IoT will be driving industries to keep on using IoT, right? If you take, right, I'm not going to go through the examples that we talked about in before lectures, because we talked about in manufacturing, we talked about robotic arms, how these things are networked together and being used. We talked about logistics, we talked about how the logistical tracking of each package happens using RFID technology or any RF technologies. Then we have transportation part of the logistics, right, either through trains, trucks, lorries, flights, or ship, right, and how these movement of these vehicles can be tracked. We talked about healthcare, we talked about so when coming into healthcare, all the scanners in the world is now a part of IoT. They have the sensors, they have the ability to process the data which has been raw data which has been obtained by the sensors, and that data can be accessed by doctors, specialists around the world to diagnose it through the internet itself. Plus the security factor of healthcare data is also in a high level, right? Then we talked about agriculture, energy, maintaining of grids, taking weather conditions and from IoT devices and deducing how much electricity would it be consumed, things like that, and making a efficient energy consuming atmosphere in a smart city, or from a smart house to a smart building, and so on, for a smart city to a entire country that can be used. So as we talked about the growth, right, the market growth of IoT, industrial adaptation industrial adaptation in different industries are still taking place. If you take any one of these industries in South Asian countries, again in African countries, adaptation is yet to happen, most probably. High-end, some big companies like Mars Holdings and things like companies like that are currently using IoT products, right? IoT solutions for their products, but that is mainly in the mainstream companies. There are yet to be implemented in medium or small scale companies in these countries. And even if you take developed economies, right, even developed manufacturing economies, IoT solutions, use of IoT solutions are still going on. Adaptation of IoT solutions, especially in heavy industries such as mining, steel manufacturing, fertilizer manufacturing, or if you have cement manufacturing, these industries that use a lot of power, a lot of mechanical power, and which is done in large scale, they are still in the transition phase from IoT, from legacy systems, either from M to M towards a fully IoT system, right? Where that is where OT, we talked about OT, that comes into play. So industrial adaptation is still there. After the industrial adaptation, when an industry or a company or a set of companies adapts some technology, right, either custom made for that industry itself, adapts IoT technology, then maintaining that devices, building, expanding, maintaining, managing, so on and so forth, have to be also carried out. So those marketplaces, right, maintaining OT, right, the maintaining of databases, maintaining of IoT networks, maintaining of IoT devices, the physical devices, expansion of IoT devices, adding more devices into the network, right? So things like that, monitoring the health of each IoT devices, so on and so forth. So that means that market space will be there always. Once an industry or a company adopts IoT technology, maintaining that IoT technology, right, is also will be a part of the IoT marketplace, right? So as we talked about market size, market growth, and industrial adaptation, right, I have listed some of the things that can be seen on or startups and different companies are working to create through IoT. So smart agriculture systems, right, we talked about them, right? Again, the vast quantities that is needed. So when think about the industry adaptation, think about the situation in Sri Lanka and how far we have to go when coming into IoT in these sectors. Think about how other countries are working, right, and how automation, especially when coming into agriculture, the part of automation is being used, and any automated device would have sensors to take in data and to see if it is working correctly. So and of course the market size and growth. So both of them together, right, these are few, not all the topics, these are few of the topics that going into 2024, 2025, what we can see products would be coming out. So or other startups and other companies are working on products. Already products are out there. Still there will be these systems being developed or worked upon. So Smart agriculture, weather reporting and monitoring. We went through weather reporting and monitoring examples plenty. Home automation, which is the starting point or the basic point of IoT. Face recognition bots, smart garages, so that would be a part of home automation. Smart garages, smart garage doors, right? Then smart alarm clocks, again home automation. Air pollution monitoring systems. So when we talk about smart cities, or when we talk about the future, industrialization of countries, right? When countries develop, they go through industrialization. With industrialization, air pollution follows. This happened when United Kingdom transferred in the mechanical revolution. It was followed by America when its industrial stage began after around World War II and after World War II. Then it shifted from United States. Then it shifted to China, and China throughout 2000 even till now they are facing air pollution. Now it is a part of India, right? Air pollution is now part of India as the industries grow, right? We in Sri Lanka was affected by that air pollution. If you remember the news cycle, right? There were some. There was a time that even we were affected. So that means that if you take in different countries, air pollution monitoring system as an industry, air pollution monitoring industry, the collection of that data, the processing of that data, the real-time sharing of that data, right, monetization of that data, that industry itself, it shifts from either country to country depending on the economic situations, proximity situations, and so on and so forth. There were some news these days because of wildfires in Canada area. United States, cities in United States and Canada is having air pollution due to wildfires. So that's a different kind of pollution, right? So that means that the need of such systems exists, and sometimes it would be a temporary cause, and sometimes new opportunities. Let's say Mexico or Brazil is now coming powerhouses in the global economy. Their manufacturing is going up. If that is the case, Vietnam, the manufacturing is going up. If that is the case, air pollution monitoring as a industrial, like in industrial scale, start in that particular IoT solution, given that IoT solution can be a choice, right? There will be a market space for that. So industries will be born out of it, or adaptation of IoT technology to monitor air pollution will be born out of necessity due to growth of the economy itself. Smart parking systems, smart traffic management systems, that would be, those two would be a part of smart cities. Smart cradle systems, smart home automation, smart gas leak detector bots, or smart gas leaks detector systems. This option, if you take this option, right, that would be something, right, that market space would be divided into home, in smart homes, solutions having safety options having in smart homes, and in locations where either gas is packaged and delivered, manufactured, and in pipelines where this gas is delivered. Sometimes in cities this gas is delivered through pipelines. So detecting leaks is a very, very important point. So using IoT devices and getting real-time information um, is necessary as well. So that would be an option, and still it's a growing industry, because in Sri Lanka we haven't still turned to pipes, delivering gas through pipes, right? There was initially talk about using that such a system in port cities. So that means there's the possibility of having IoT devices to detect gas leaks in pipes in Sri Lanka as well. So the industry is yet to be born in Sri Lanka. Street light monitoring systems, smart anti-theft systems. Street light monitoring systems would be smart cities, and smart anti-theft systems, from home automation for buildings to cities, that can be different, because the different solutions depending on a mixture of motion sensors, cameras, smart locks, fingerprint readers, face recognition, so on and so on. Liquid level monitoring systems, yes, we talked about it as well. Water reservoirs and so on and so forth that we have to use. Night patrol robots, again, is security systems, health monitoring systems, smart healthcare options, we talked about it, flood detection systems. So again, this is a part of smart weather, right? Depending on the information from different IoT locations, the moisture in the soil itself, right? We can detect whether a flood can occur or not, right? We can calculate that. Mining workers, safety helmets, or mining industry itself relies heavily on IoT solutions. Smart energy grids, contactless doorbells. We will come back to contactless doorbells in a while. Virtual doctor robots, this is something still going on in experimental level. Smart waste management systems, smart cities. Forest fire alarm systems, again in smart city, it could be a part of smart cities, or it's a smart city solution or a smart country solution, depending on the adaptation. So on top of these up and coming industries, right, there are plenty of other industries. We didn't even talk about the defense industry, right? The amount of IoT devices which are being used, either surveillance, drones, right? The amount of sensors that is available in fighter jets, to tanks, to night vision cameras, motion sensors, radars, so on and so forth. That's a different sector which uses heavily depends on IoT, right? So, and of course there is the need of IoT, or the birth of new industries, depending on the situation, right? So we talked about pollution monitoring, and we talked about how that in different countries that pollution monitoring industries, right, could start up or will be born out of necessity. Another one of those examples would be contactless doorbell and other contactless systems. Why? Because the best example would be the coronavirus situation we had. Contact between door handles, doorbells, switches, and so on and so forth is, we were told to reduce them as maximum as possible. On top of that, if right? So the toolkits which are being used to monitor the virus, to detect the virus, right? We wanted to make it with much IoT properties as possible. So quick detection, simplification, so quick detection, analyzation, things like that can happen, and quickly respond if somebody is infected. So then we had thermal cameras, thermal systems checking whether people have fever or not. So there were solutions, right? There were smart air filtration systems built for for stopping the spread of the virus, and so on and so forth. So not only corona, there will be other viruses, or there would be other issues that the human race will face. In that case, if you are an IoT engineer, if you are working in IoT company, or if you are starting a IoT startup or something like that, you can be the one who comes up with a IoT application or IoT solution for that problem and create a new industry. So when coming into industry adaptation, there are two sides of it, right? Existing industries dropping legacy systems and introducing IoT systems to optimize process, improve efficiency, and enhance customer experience, right? That would be adding value to that particular industry. So depending on the industry, when we talk about smart grids or whatever the solution, right, all these solutions in different industries, most of the things does is optimization of process. A process that may take a long time to respond, a process that will take long time to fix, or improve efficiency, as in before the issue fails, right? Before a issue happens, we can monitor and prevent it. So things like that, right? So the most successful and financially viable thing is stopping the disaster before it's happening. So nobody will know the effects of it, but it is the most convenient way of handling it. That would be a part of enhancing customer experience as well, right? If you can stop a robbery before happening it through a smart security system, giving real-time alerts, right, monitoring real-time, so on and so forth, that would be a much better outcome rather than the robbery happening and going through the hustle of finding the robbers, things like that. So in the fast moving world, right, we know that automation is something that we cannot avoid. Companies are moving towards automation to reduce human error and to be more efficient, to produce more product in a shorter period of time, right? So and machines does not get tired like humans. So there's a advantage point for that as well. So automation will take place and will keep on taking place in this world. So in that perspective, industries will keep on adding sensors and actuators to their machinery, to their manufacturing lines, to their process. If that is the case, then that means IoT will be there, right? And industries will keep on adapting IoT, right? As we talked about in market size growth, right? Industrial adaptation will also facilitate market growth, and industrial adaptation will keep on happening as well, because we told when we were talking about market growth, we recognized that there is a large untapped marketplace in the world, right, beyond the existing marketplace. So growth is imminent. That means there are industries still willing to adapt or still waiting to adapt IoT solutions, but again, to industries to adapt IoT solutions, it should be financially viable and cost effective rather than the existing solution. That is one of the main points, because we live in a capitalistic society, and any industry to adapt IoT, the value IoT gives to that company have to be far greater than the existing system or the legacy system. So that is also one of the points that we have to recognize when coming into industry adaptation. So after looking into market size and growth of IoT, then industrial adaptation of IoT, right? Then we have to talk about the other topics: connectivity and devices, data analytics, right? Security and privacy standards, right? And startup innovation and regulatory environments. We will talk about this on the next lecture, right? We will briefly touch upon each topic and see what is there in a market perspective, especially coming into after connectivity and data analytics, right? These would be going under basically services, right? What are the whether the industries or the growing marketplace, right? We talked about those two topics. So what does a growing marketplace and industries need? Connectivity and devices, data analytics, those solutions, right? Security and privacy in a market perspective, right? It is needed for each and every IoT device. So market perspective of security would be for all, right? If you are building an IoT device, if you are giving IoT solution, right, we cannot walk away from security. Rest of it is the market perspective in general. Regulatory environments would be right, it is something beyond IoT industry's control maybe, but we should adapt accordingly, right? Startup innovation, same situation. So after that we will be going into checking value chains, right? Understanding value chains, M2M value chains, IoT value chains. Then we will be briefly going through what are the topics that are there in the value chain, right? If you are IoT company, if you are going to give a IoT application or IoT solution, right? What kind of a company or what kind of a solution that you can give, right? So there's the device, connectivity, cloud, right? This application development, system integration, data analytics, service providers, end user and customer. So we will talk about those topics which are much more needed. Those are the main topics that we have to check when talking about IoT marketplaces, right? Because each and every sometimes there are companies that provides all of these features in one bundle, but in some cases you will need to have a mix and match of different solutions, different service providers to build an entire IoT application. So we have to talk about that part as well, right? So for now we have covered close to 2 hours, right? We can end our lecture from here for lecture number 5. We can end it from here, right? So you will see in this lecture 5 and going into lecture 6 which are the topics that we are going to cover. So it's mostly in it's a market perspective, checking out what are the markets there and what is the general market perspective. Nothing, we won't be going into much financial details or things like that, but a general idea of the IoT market space itself. Okay everyone, I think we can stop the lecture from here. So see you in the next lecture. Have a great day everyone. Take care.